So now we're going to go through the software part. So usually the LSM 780 computer is pretty much always on. If it's not on, then you have this after you turn it on, you have this interface. You just have to do Control-Alt-Delete. Okay, and then it's LSM user as username, and the password, there's no password, so you just need to click enter or click on this, and then it's going to go in. Okay, we're going to wait a bit. So now you have this interface. Okay, so here you have those three buttons. Hopefully you can see it. It does have a bit of reflection. So ZEN 2010, this is the operational software. And then your user shortcut, this is where you save all your files. You're going to save it here where you have everyone's name. You can create a file for your lab or create a file under your name as long as you can find it. We don't really care that much. We try not to wipe it clean very often. We only wipe it when the storage is almost full and it's going to affect the operation of that software. In that case though, we're usually sending email to all our users. Although if you're using someone else's account to book through iLab, then the email is going to send to that person, not you. So just be a bit careful. We do highly recommend you to back it up every time after your session is done. If you forgot your USB key, at least back it up once a week or something, because we usually do wipe it clean about every 3 months to a half year, depending on how much data we collected. If you forgot your USB key, you don't have to worry about it. You can copy your file from the users to this one, molecular imaging share, and then go to temp. And this is the server that's internal, okay? So if you do paste the file to this folder, then you can get access of your file in the artwork analysis room. And over there, you're going to have the same file that's called molecular imaging platform shares. And then once you put your file there, you can access your files through there, okay? But keep in mind that this is not really a storage, it's more for transferring your file. Once this is full, we're going to completely wipe it out, okay? So please make sure that you always have a backup on your side, either a USB key or a hard drive, or if you prefer to store it online through a cloud, you're welcome to do so. All the offer stations are linked to internet, so you can actually store it in your Google Drive or your Dropbox. So for the software itself, it's this one, the ZEN 2010. Okay, so we're going to double click this. Okay, so now you have this interface. So you have image processing, which is here, and then you have start system. So image processing is always for editing pictures. You don't need to edit your pictures here. We have the artwork station for it, where you have the exact same software. You can use that one to do any kind of analysis, like measuring a certain wavelength, at scale bar, export them into T for JPEG formats. All of those you should do it in the artwork station, because that is completely free for our microscope users. For here, you are paying to actually use the system, so you're going to click on Start System, and then this is where everything's linked. So you have this small triangle here. If you click on this triangle, you're going to see what is connected. If there is any errors, it's either going to show up here, okay, as it's not connecting properly, or you are going to have an error log that is down here, okay, and you're going to see that error log in a few minutes. Here you go. So here, usually there are a few errors that you don't really need to worry about. If this error log shows anything about CO2 error temperature is because this component here is not turned on, so obviously it's not connected to our software. If you see anything about focus stabilizer, is because of this definitely focus, which we're not using for fixed sample either. So if you do see those errors here, you don't have to worry about it. But if you see errors such as organ shutter not connected or excite not connected, so those are the components that you most likely need to use unless if you choose to not turn it on. In that case, you're going to close the software itself, and then you're going to check if all the components that you need are turned on properly, and then you're going to reopen the software and redo the start system and let it connect. It's very important that all the components are connected before you start using the system, otherwise you're always going to run into a bit of trouble. Okay, so now we're going to look through the software itself. So if we see up here, okay, you have Ocular, Acquisition, and those are the two that you need the most. Okay, Ocular has the I symbol here. It's for the eyepiece, for us to see our sample before we start imaging. So this is where it's controlled. So this interface is very simple. You're going to click on Online, and then you're going to click on whichever color you need. So you have DAPI, GFP for any of your green fluorophore, rhodamine for any of your orange-red fluorophore. Keep in mind that if you are using Alexa 633 or 647 or APC, most likely you won't be able to see it through this rhodamine because the light itself is not the same as what you're going to have for rhodamine. So if you want to use that to choose the area, you need to screen it with laser, whereas all the other colors are visible with lens, which you can use directly the eyepiece. Okay, here you're going to use directly the eyepiece to find the area of interest and find the focus. Okay, so back here. Now you're going to click on, you clicked on Online, and then you click on whichever color you need. Okay, so if you see that I click on the color, this part lights up. Okay, and this is a diagram of how the light is passed through. So we're going to talk about it later. So if you need to see DAPI, click on DAPI. If you need to see green, you click on it. If you need to see red, you click on it. It's that simple. If you need to see bright fields, you can click on DIC2 or DIC3. Okay, either one of them are okay. I tend to use DIC2 most of the time just because it'll work for pretty much all the objective, whereas this one usually works a bit better for higher MAC objective. Okay, so you can see if I click on DAPI, this part lights up. Okay, and if I click on the bright fields, this part lights up. Okay, so the reason why is because this is a diagram of how light passes through. So for DIC, we're using the halogen light bulb, which I explained in the hardware components module. You can refer to that one. And that's where the light is, and it goes through here, and then it hits, this is our stage, and then it goes to our eyepiece. The light get reflected to our eyepiece. Whereas for any of the fluorescent light, it is from the excite, okay, and then it passes through, hits filter, and then it goes through the objective, and then it goes to the stage, and then the light get reflected to our eye. Okay. If the light is too strong or too weak, you can use the light source to increase or decrease the light source intensity. You just need to click on here, and then you can drag it here, or you can enter the numbers here. Keep in mind for fluorescence, you have a possibility of bleach your sample if you do increase the light to say 100%. Okay, so usually we do put it on default. For rhodamine on LSM 780, the default is 25%, and for GFP, I think it is 12%, if I remember. Okay, yeah, the default is 12%. You can increase or decrease it, although the lowest one is 12%. If you go lower than that, it will be 0. But keep in mind that the higher the intensity of the light source, the more likely it's going to photo bleach your sample, and you don't want to photo bleach your sample before you actually get the image. So be very careful with it. Usually the default 12 or 25% is more than enough to see your sample. Sometimes if the staining is very strong, it will be even too strong. Okay, but you can obviously increase or decrease intensity to meet your purpose. For the bright field is the same thing. If you click on the bright field, this part is going to light up, and this is the light source, and you can increase or decrease it here. There is a place that you can increase or decrease the bright field light intensity other than the software, and it's here. So if we go to the microscope itself, go under here. So this wheel, this you can increase or decrease the bright field, because it is actually something up there that's open or close the light source to allow more light in or allow less light in. So you can decrease it here, and this is actually connected to the software. So if I decrease it here on the software, it's going to go lower as well. So they are all interconnected. However, this does not work for fluorescence. So for fluorescence, you're most likely to need to use the software to increase or decrease the light intensity. Okay? Now, if we're back to the software itself, so under here you have the objective, okay? And this is the list of objectives that is here. So the objectives are different, a bit different to all of our confocal microscope, but they all have 10x, 20x, 40x, 63x, and 100x. So 10 and 20x, you can see that it's dry objective, so it means there's no immersion media. 40x, you can see that it says oil on this one, so which means this one you do need to use oil as an immersion media. 63 is the same as oil, and then 100x is oil as well. Okay, so for those three, you need to use immersion media. For those two where it dries nothing, it's dry objective, so you cannot use the immersion media. Actually, if you do use immersion media on those ones, your image will come out blurred, not as focused. Okay, so you need to be very careful if you are switching back and forth between the oil ones and the dry ones, because if you put oil on this one, you won't be able to focus properly, especially the 20x. The objective is very close to the sample. It's very easy to get oil onto it, and then you cannot focus properly. Whereas if you don't put oil on any of those objectives, you won't be able to properly focus either, so you need to be very careful. Now keep in mind, this is LSM 780. For your 880 and your 780 IR microscope, the 40x is usually a water immersion objective, which you can use a regular distilled water, or you can use the glycerol that is provided by the platform, because water evaporates way too fast sometimes. So keep in mind that you do need to check in the list which objective it is before you actually apply any immersion. For LSM 780, it's usually all oil, and the oil that you're going to use is this one. Okay, so for it's this one. Okay, so for each room, we do have a bottle like this. This is your oil, the oil that you're going to use for the immersion. You're not allowed to bring your own oil from the lab, because for each microscope, the components are a bit different, and sometimes even if they're the same type of microscope, the audio component is actually different depending on what type of objective there is. Okay, keep in mind that for any water immersion, it's not this one. Okay, there is a bottle that's very similar, but it has a dot on top. So that dot means that one is all, water immersion, not oil immersion. And don't misuse those two because you won't be able to focus either. Okay, so this is pretty much all you need to know for see your sample through eyepiece. Let's go through it again. So I'm going to click on offline. Okay, so if you want to see your sample online, whichever color I need, okay, and then you can see your sample through eyepiece, and then after you find the focus and find the area of interest, you're going to click on offline to turn it off. Okay, so bottom here, this is the incubator part. This is usually turned on if we do live sample. So you have the temperature control, and then you have the CO2, and we can talk about this more if you are going to do any live sample experiments. Okay, so next we are going to go through the acquisition part.